So, hello, thank you for the invitation. I'm Sila, and in the next few minutes I will talk you through in trends in visual function in childhood and health inequalities in a joint work with Phil Cumberland and Jug Nourahi from the Vision and Eyes Research Group of the Institute of Child Health. So the interest in this work came from a previous work done from our research group in the biobank data, investigating social determinants of visual function and social determinants of inequalities in visual health in adults. So far, there is an extensive interest in investigating social inequalities in other health states, and this also includes blindness and visual impairment. Both of them were found to be adversely associated with social outcomes. However, due to this prioritization, less attention was given in a vast majority of the population, and this for the UK is around 25%, that may also suffer from near normal or mild impaired vision, which also might affect activities of everyday living. So results of this study shown that all-cause impaired visual function was adversely related with employment status, occupational status, income, and self-report measurements of general health and mental health status in a gradient of increasing severity ranging from mild impairment affecting one eye to bilateral blindness. So, for example, somebody, the risk for being unemployed or even unable to work was increased as visual function has been decreased, or similarly, someone with has been in a higher risk of being in a lower grade occupation category, while being in the highest categories, in the most severe categories of visual impairment. In addition, social status, including educational status, have also been found to be a major risk factor for visual impairment across the whole spectrum of visual function. So, although social inequalities and visual impairment has been investigated in adults, this is limited in childhood. So considering this gap in the literature, we aim to investigate whether the distribution of visual function has changed over time during childhood, and whether the current pattern of association between visual function and social class that is being in adults finds its origins in childhood. To answer our research question, we've used data from 3 national birth cohorts. Although different questionnaires and different methods were used in all these cohorts, similar information was collected, and they, including measurements on visual acuity, and they all served similar purposes, so we can evaluate time trends and between cohorts comparisons. Our main interest was in visual function, which is mainly measured through visual acuity. So visual acuity is actually refers to clarity of vision and has been used as a measure of visual health. It's been conventionally measured by putting a chart with letters or shapes on a certain distance opposite a person. This, for the Snellen chart, is 6 meters or 20 feet. The person goes through reading the letters in each line up to the point that they cannot recognize them. So, for example, if a person can read the letter in the first line, this would mean that at 6 meters, they are able to see a letter of a certain size that is normally seen from the 60 meters. And similarly, if somebody can read the letters in the 8th line, this would mean that at 6 meters, the person can read a letter that is normally seen at 6 meters. So if somebody cannot read beyond line 4, the maximum that they can read at 6 meters is a letter that can be normally seen at 15 meters. So as you may understand, if as you are standing in a distance closer than the one that the letter can be actually seen, then it is expected that a person could read all the letters. However, if they cannot read letters after a certain line, this would mean that their acuity is being reduced. However, the Snellen chart has certain limitations, so another chart has been developed. The difference both in the setup of the chart, also in the difficulties of reading the letters, and in the total score that has been calculated. So for example, by using the Snellen chart, since there is one letter in the first row, the person has 50% chance to read the letter correctly. While using the logmark chart, there are 5 letters per row. The size is decreasing logarithmically as the distance between the lines. And this allows the chart to be used even in non-standard viewing distances. And a total score can be then calculated by accounting all the letters that has been correctly written by the person. And an actual score in a continuous scale can be calculated, while by using the Snellen chart to actually have a categorical outcome. However, although the logmark chart has been used since its development, since it provides a better, more accurate estimates, the Snellen chart has been used in most of the time points during the cohort studies, and has been used as the logmark chart has been developed after 1976. If it's necessary, there is a formula that has been developed to convert from one scale to another by taking the natural logarithm of the reverse Snellen scale. So for example, if a person is able to see at 6 meters a letter that is normally seen at 19 meters, then its acuity is calculated at 0.5 using the logmark chart. And in this table here, you can see the equivalent values of the logmark chart for certain values of the Snellen chart. So starting from the 6/5 or 6/6, acuity is decreased as the Snellen values decrease, but decreases as the logmark values increase. And we can then use this information to classify individuals into one of the modified visual function categories, ranging from bilateral normal to bilateral blindness, taking into account the best seeing eye. Data on vision were available in all these 3 cohorts. The Snellen chart was used to record acuity till during adolescence, while the logmark chart was used to record acuity in adulthood for those who have been born in the 58 cohort, and at the same point refractive error was also collected. And there is a certain amount of self-report measurements that have been collected across the whole life course for all 3 cohorts. So for the purpose of our analysis, we have used data at 16 years old, as children were born with a 12-year gap between the 3 cohorts and have actually been assessed on the same time point. During the same length of the disease development, they have been exposed on different factors. So we can then investigate time trends and any differences, for example, occurring in visual function may reflect a cohort effect. In this table here, you can see how the acuity measurements were recorded in all 3 cohorts. And as you may see, there are certain differences, especially in the extreme values recording. So we've decided to group those together. Fortunately, the Snellen chart was used in all 3 cohorts, so no further conversions were required. And we were then able to use information from both left and right eye in order to classify participants in one of the categories, having normal acuity, unilateral visual impairment, socially significant visual impairment, severe visual impairment, and blindness. However, due to small numbers in these 3 categories, we've decided to group them together. The final sample size that was available for our analysis was just over 14,000, which is actually 2/3 of the available data that were collected when the cohort members were 16 years old. Unfortunately, in order to have robust variables, especially in the socioeconomic measurements that we were to use, we had to lose about 1/3 of the data, mainly due to missing data in the early life social factors. So we've been interested in early life social position at birth and childhood, and for that purpose we've used maternal educational level at birth and father social class when cohort member was 11 years old, which both of them were harmonized within the closure initiative. In this chart you can see the distribution of age that cohort members' mother left schooling. As you can see, this peak here reflects the minimum school leaving age, and there is a shift here indicating a change in the age limits that has been introduced by law following some educational acts some points later. So to accommodate for this shift, we had to use the maternal age at birth and the actual cutoff points that the actual years that these changes have been introduced in order to classify cohort members' mothers in one of the categories of statutory schooling, extended schooling, and higher education. Mothers who left school before 1918 were mainly from the 46 cohort. Those who left school between 1918 and 1974 were mainly from the 46 and the 58 cohort, and those who left school after 47 were mainly from the 58 and the 70 cohort. So following this rationale, we can see that the proportion of mothers who stayed longer in full-time education has been increased over time. And similarly here you can see the distribution of father social class when cohort member was at 11 years old. Again, due to some small numbers in certain categories, we decided to group them together as unskilled, skilled, and professional. And to some extent, we can see that father social class also improves over time. So results of our analysis, our findings indicate that there is a continuous, albeit minor, decline in the proportion of 16-year-old participants with normal acuity that has been actually attributed to an increase in all categories of visual impairment, ranging from unilateral visual impairment to social significant and severe visual impairment and blindness. And this pattern actually remained even after adjustment for sex and early life social determinants, although there is a U-shaped curve and a reversed U-shaped curve and a U-shaped curve noticed for the social significant and the visual impaired categories. So following our rationale, we calculate the predicted probabilities for being in each of the categories in visual function and for a certain, for a given maternal educational level and father social class. So for example, if we focus on the unilateral visual loss, we can see that with the red line are those born in the 46, the green line those born in the 58, and the blue line is the 70 cohort. So you can see that there is an increase over time in the probability for being in this certain category, which has been actually attenuated as father social class improves, but has been increased as maternal education improves for a certain level of father social class. This pattern was similar for those in the social significant visual impaired group, but it was actually reversed for the severe impaired group. Here we can see that the probability for being in the visual impaired group is actually increased as father's occupational social class improves for a given maternal education level, but is increased as maternal educational level at birth increases. This trend was quite evident among females. So if we focus in the unilateral visual impairment category, we can see that females were more likely to be in that category as compared to boys with similar background. And this pattern was similar, although more evident in the other two categories. So our findings indicate that there is a decline in visual function in childhood over a quarter of century during 1961 and between 61 and 1986, that has been attributable in all categories of visual impairment, ranging from unilateral visual impairment to blindness. And the cohort effect that is noticed here is associated with gender and social position in a more complex pattern. So these findings might reflect availability of prevention or treatment during this period, which might have led to an increased survival of preterm infants or of those with complex systemic conditions, that they were in an increased risk of developing visual impairment. The association between social position and visual function in childhood that has been seen here might be strengthened in adulthood, and this is what we can see currently in adults. And the gender inequalities that have noticed here are in line with current and projected inequalities in adults. So to conclude, the cohort effect that we have noticed here, boosted by the socio-demographic status at that point, might be related to the pattern of blindness that we see now. And the current association, the current pattern in social status and visual impairment that we can see in adults might find its origins in early life social position. So I would like to thank all the participants for the continuous enrollment in the cohorts, all the staff that has been involved in data collection and data management and harmonization, the funders, and you for your attention.